Hi guys, and welcome back to JC Geography Support channel. Please make sure that you like and subscribe below. So today I'm going to run through paper 2, okay? I'm going to do like a recap. It might be about half an hour or so. I'm going to run through it. I'm going to do it in 2 parts. I'm going to do the physical landscape part 1, and then I'm going to do the physical landscape part 2. So this first one, I've got the textbook here with me as well. I've got these little prompts. So let's see if we can talk our way through. So this unit starts with looking at the past and looking at the geology, looking at the landscape in the UK. And I will do another video, I think, on some of the 12 markers, which are the 8 markers with the force bag that in paper 2 that use some of the physical geography to ask about kind of like where the people are, what kind of like issues there are with people, population densities, or people living on coastlines, etc. So I'll do a video on that separately. So let's get into this one. So the geology starts off with the geology of the UK. Now, the geology of the UK is, if we imagine a map of the UK, the east of the UK and the south and the east is mostly softer rock, and the west of the UK is mostly harder rock. So the geology has got quite a lot of impact on the landscape. And the harder rock in the west means that those areas are eroded less, and the softer rock in the east means that those areas are eroded quicker. So that has quite a lot to do with the human geography that we're going to get into in the next part of the unit. So it starts with looking at different parts of the UK and how they got there. So the textbook talks about coral reefs and the Pennines, and really that's got to do, that geology is obviously limestone, which is a sedimentary rock, and tectonic processes worked on those areas, because the UK used to be much further south when it was part of the kind of European continent, when it was part of the kind of Pangaean, that kind of thing. So as it pushed northwards, it kind of started splitting up. Parts of the UK were underwater, so we had sea creatures which kind of over time died, etc. Limestone was produced, and then the area was kind of uplifted as those tectonic processes either pushed the UK further north, or we had igneous rock and igneous kind of convection currents underneath the Earth's surface, kind of pushing the land up, and we end up with the Peak District, or the Pennines, I should say, being uplifted, and it's got lots of remnants of relic landscapes there with limestone. And then the other thing that we have to make sure that we know about is the glaciation that happened in the UK, and how that kind of like scoured out the Lake District, the kind of the U-shaped valleys, and changed V-shaped valleys to U-shaped valleys, and how really it moved further south, and when it got into the softer rock of the southeast and the south, it kind of like eroded that, and then remember that it dumped a lot of its load after it melted. The glaciers melted, it kind of dumped that on the kind of east of England and southeast of England. So we've got really soft rock down here, a lot of clays and things like that. So we need to make sure that we have a look at the textbook on how geology, tectonics and glaciation has shaped the landscape. So just quickly, igneous rocks are obviously basalts and granites, and they're quite hard. Sedimentary rocks are a bit softer but still quite resistant to erosion, so that would be limestone, chalk, sandstones, and then we get into clays and things like that, which are really, really soft, and a mesomorphic rock, which is either of these that has been heated up, and it's quite resistant. So rock type's got a lot to do with what the landscape looks like, so we have to remember that. Now the textbook then, if I flip over, talks a little bit about a couple of areas in the UK about physical landscapes, and one is the Lake District and one is the Weald. And the Lake District, obviously the northwest of England, the Weald is in the southeast of England, near where we are. So we've got the Lake District, which is harder rock, which we've got erosional processes and weathering processes. Remember, erosion removes sediment, and weathering actually weakens it. So weathering happens first, and then that makes the processes of erosion happen a lot quicker. So we've got lots of different things happening there, and the Weald is obviously in the south of England, and it's undulating landscapes, because really this is kind of like chalks and things like that, and clays, so it was eroded a lot easier and a lot quicker, and you end up with kind of this undulating landscape. So the relief or the topography is quite undulating or low in the south and the east, and it's quite high topography or relief in the west, because that's where you've got the mountains in the UK. So that's, you need to maybe have a little look at that, those two things in particular. So next we've got a little bit on people and the landscape. If I flip over, I'm going very quickly. All of these videos, I've done lots and lots of these videos in a lot of detail, so go and check those out as well if you want a little bit more detail on any of these. So people in the landscape. So distinctive landscapes are a result of human activities, and most of these are farming. So a lot of these landscapes that we've got now are the result of farmland. So we've either forested the areas, so we've done that kind of farming or forestry, and then we've put like lots of either hill farms on the landscape, or we've put lots of arable farms on the landscape in East Anglia. So there's not only physical processes happening to the landscape, we've got human processes there, and human use of the landscape has a lot to do with what it looks like now. So it's a little bit about the Yorkshire Dales and about dry stone walls and hill farming and that kind of thing. And then also in the East Anglia and the southeast, we've got lots and lots of cereal farming and agriculture and arable farming there as well. Okay, so that's the little bit at the start, which is a bit weird, but it's about kind of the physical landscape, like I said before. And then we go into coasts. So the rest of this is going to be on coasts. So again, I've got more specific videos on coasts below if you want to go and check those out, but I'm just going to recap. So we're going to start off with erosional landscapes, and we're going to look at concordant and discordant coastlines. So just a reminder, if I get it the right way around, a concordant coastline is where the rocks are running parallel, just like these lines of writing are. You can see the red writing and the orange writing and the red writing again. So they're running kind of parallel to each other, and they're running parallel to the coastline. So that's a concordant coastline, okay? And quite often, if we get a very resistant rock, like a chalk or a limestone really, parallel to the coastline, then it takes a lot of erosion to kind of break through, and we get things like coves forming, which is kind of Durdledore and Lulworth Cove, basically down in Dorset. So that's your case study for that one. And then discordant coastline is where you've got the, if I turn that way, this is the sea underneath here. It's nice blue in the background, you can see here. The rock is running this way, perpendicular, I think it is, isn't it, to the sea. So this could be very soft rock. This orange could be harder rock. That could be soft rock. That could be harder rock. So we end up with headlands and bays. Okay, we end up with headlands and bays because we've got more resistant and less resistant rock types. So there are discordant and concordant coastlines. And again, you need to make sure that you know what the erosional processes are there. So we've got hydraulic action, we've got abrasion, we've got attrition on the coastline. So all of those are formed from the waves hitting the coastline. And then we've got weathering on the top of the coastline. So weathering kind of further weakens the rock to make it easier to be eroded. So weathering would be subaerial process on the top of the coastline, and then roots would be biological weathering, and we would have slightly acidic rainwater, maybe a bit chemical weathering, and then we would have wetting and drying, or hot and dry, or hot and cold, I should say, or wet and dry, and we would have that kind of that erosion as well. So we've weathering as well. So we've got weathering weakening the rock, and then erosion taking it away. Yeah, so there are concordant and discordant coastlines, and then we've got transportation. Obviously we've got longshore drift there. So longshore drift is when we've got the swash washing up the beach and the backwash washing back down. Again, I've got videos on all of these if you want to go and check those out. Just make sure you know those processes. And that moves material along the beach. And then that forms obviously our depositional features, which would be a spit, a bar, and a tombolo. Not a tombola, don't get mixed up with that. You don't get any prizes with that one. So depositional features, we've got longshore drift moving material along the beach. When that beach material is moved back into the sea, we've got the mouth of a river, or the coastline changes direction, as it might at the edge of this one. So we've got longshore drift moving material along the coastline, goes out into the sea, forms a spit. Okay, so it's got a little curved end, okay, curved edges, because the sea's coming in and kind of pushing that material up. And then if it hits the mainland again, then that would be a bar. And if it hits an island like it does in Portland down on the south coast, then that will be a tombolo. So there are depositional features. So make sure you revise those quite well, because you may well, I know the last few years they haven't really asked too much of that, but they might do this year. We're always waiting for these big questions on these, but they haven't seemed to be such a big question. Now, next one is human activity. If I go on a little bit from the book, we've got human activity here, which is obviously along the coastline. We have got farming, obviously, and then we have got housing being built or industry being built. So that all has an impact on the kind of sediment cells, because we start protecting the coastline, we start putting groins in place, etc, etc. I did miss waves off here. Just make sure you know the difference between constructive waves and destructive waves. So constructive waves build up the beach, and they normally happen in the summertime, remember, and then destructive waves are much stronger waves which happen in the winter, and I've got a stronger backwash to the swash, so the material gets dragged down the beach, and that causes a lot of erosion. So concordant coastlines are often quite shallow, and waves, constructive waves, are often quite shallow. The sea is often, the relief is often quite shallow. Nice, not very steep beach. And then when we've got a destructive waves, they're very, very, they kind of scour the sediment out, and we end up with these very steep beaches. So, a bit of a mess there, but never mind, you know what I'm talking about. Human activity, like I said, houses, industry and agriculture have an impact on the coastline. And then risks of flooding. So, there's a little section here which talks about sea level rise. So obviously when we've got the issue of sea level rising, where we've got quite low level land, we've obviously got a lot of issues with those areas being flooded in the future, especially when we've got areas southeast of England or small island nations, etc. So they're very much at risk of flooding. Okay, so a little bit on that, tidal surges and things like that. And then we've got management strategies. So again, I've got videos on these, but just to remind you, you've got hard engineering, which is things like groins, seawalls, revetments, that kind of thing. So if you remember the pros and cons, make sure you know the pros and cons of these, because your 8 mark will often be, I think anyway, it might be on this. So hard engineering does what it says on the tin, but it's expensive, it's often ugly, and you limit access to the beach as well. And also taxpayers have to pay for that, and a lot of people who don't live right on the coastline maybe don't want to pay for that. So you get a bit of conflict happening here. Soft engineering is a lot more sustainable, but it doesn't last as long. And then remember, when we've got sustainability, which has nearly disappeared here, you need to be thinking of your shoreline management plans. So what happened in the past was that engineering would often happen just wherever it was needed, but that caused lots of issues along the coastline. So where you've got groins being put in, the last groin caused terminal groin syndrome. And if you've got the case study of Holderness, then you may well have seen the cow video of the man with the cows. And it was Cowden Farm, I think it's called, and the man had cows there, and then the terminal groin syndrome happened to the north. His kind of land was destroyed further south, and he had to move, and that because all his land got eroded into the sea. So that was terminal groin syndrome because of hard engineering. But soft engineering is things like beach replenishment and that kind of thing, and that is often more sustainable, because hard engineering is not sustainable in some ways because it does cause issues down drift, but you could argue it's a little bit sustainable because it does help with the area that it's supposed to be protecting. So when you look at sustainability, you need to be looking at your shoreline management plans, and like I said before, that means that the whole of the coastline is looked at, so it's often called holistic approach to management. So either sustainable or holistic. If it talks about that in the exam or asks you to evaluate, then often that's better because it doesn't cause issues in the future. But if you've got like a big city, then you're not going to be able to put soft engineering there because it's going to destroy the city. So you can use a little bit of both there when you're talking about sustainability, because you do need a bit of hard engineering, otherwise it's not going to work, because you can't really move big cities out the way. So just be aware of the pros and cons of these. Now that was very, very quick, but that is my first part of my video, which was the physical landscape. The next video I'm going to upload will be on rivers. So this one is a little bit on that top bit on geology as we start the unit, and then on coasts. So make sure if you need any more information on these, you go and check out the individual videos, which will give you a bit more information. But that's just a little recap. The next video is going to be on rivers.